Okay, in this video I'm going to make the horse's hoof tool. I'm going to design it, cut it, shape it, test it. I'm going to grind in the nail nick, heat treat it and polish it. Please let me know what you think. I'm trying to get better at making videos, so it would be great if you could comment and tell me what I've done badly and how I could improve. Thanks. Also, I hope it's not too long. Please let me know what you think about that too. I tried to keep it as concise as possible while still showing all of the steps, and I wanted to get the whole hoof tool made in one video. So the first step in making custom tools for Swiss Army knives is to make yourself a fixture plate. Now this allows you to assemble layers of the knife, one layer at a time, onto a nice rigid, stable work surface, and you can then test out how the parts fit together, how they move, how they pivot and interact, without having to assemble the knife each time. So this is basically a plate of aluminium, 10mm thick, with 4 pins pushed into it, which represent the 4 rivets in the knife. And then you can assemble the back spring and the back tool and the 2 front tools onto those 4 rivets and test the operation of the parts. So next I'm going to show you how I made it. Okay, so we're over at the poor man's milling machine, which is to say the lathe with the vertical axis mounted on it. And I've got an aluminium plate mounted on the Z-axis, and I've glued one of the liners from the knife onto the aluminium plate with super glue. And I'm now going to line up the hole pattern and drill through the plate to make the holes to hold the pins. So I've measured the holes. They are indeed 2.2mm, maybe plus a absolute tiny smidgen. I'm going to drill the plate 2.2. The rods that I've got are about 10 micron or 20 micron under 2.2, so that will be a good clearance fit. I can just Loctite them in place. So yeah, just to line up these holes, I've just flipped the 2.2mm drill bit around in the chuck, and I'm using the back end of it to just locate the hole to get to the point where it perfectly goes in the hole without deflecting either way. So yeah, ideally I'd use something like a gauge pin, but I don't have the right gauge pin, so yeah, that'll do. So I'm going to flip it around. Now I'm going to use a 2mm center drill, then I'm going to drill it 2mm and then drill it out to 2.2. Let's do it. Right, that's the center drill. That's the 2mm. Through through 2mm, and then we'll go through 2.2. And now we're going to do the same on the end holes, which are 2.5. Right, it's time to unglue the scale from the plate. I've never actually used, well, say never. I do sometimes. Usually I would use shellac in this kind of situation, because you've got two options. It dissolves nicely in alcohol, and you can release it with heat very easily. You can just about dissolve superglue. Well, you can dissolve superglue in acetone, but it's much slower than dissolving shellac in alcohol. So yeah, but somebody kind of encouraged me to give this a try more often, so I'm going to give it a go. I'm sure it's no drama. The only thing I've got to be really careful of is to not bend the plate, because it's only oh Jesus, words, liner, because the liner is only 0.7mm thick aluminium, so it's very, very easy to bend. So let's go. Let's give it some heat. Very important to not breathe the fumes of decomposing superglue. They are absolutely noxious. I remember I got some in my eye once, and it was extremely painful. It might even be cyanide that it decomposes into. I'm not totally certain, but it's not great. So I heard a big crack there, so maybe that actually has already let go. That would be pretty surprising. And I'm trying to get under the glue rather than chewing up the actual aluminium itself. Oh yeah, look at that. Well, that was no drama, was it? Right, so I've assembled the this layer on the on this fixture plate. So I've got the Phillips screwdriver and magnifying glass. This is the tool that I'm going to replace with the horse's hoof tool. So I've got to design that to fit. So with the back spring assembled on here and the screwdriver in place, I'm going to take some photos that'll allow me to design the horse's hoof tool, particularly how it's going to clear the magnifying glass as it closes, and obviously how the back is going to interact with the back spring. So the land sort of shape on the back of the tool obviously defines how it snaps into place against the back spring. You can see this one has two lands, so you can sort of latch at the 90-degree position for more torque or whatever, and close obviously. Whereas the magnifying glass just has a single land there. So yeah, so I'm going to take some photos now. Now on the plate here, I've put some reference geometry down here. Just put two center punch marks, very precisely spaced, 130mm, and another one down here, 50mm down. So that'll allow me to obviously register everything up when I import the photo into CAD, get it all precisely scaled. All right, let's do it. Let's take some photos. All right, so I'm trying to figure out a good way of imaging the knife. Flat bits I will probably end up scanning, but to see the whole assembly mounted on pins and so on, I could make some short pins so that it's flat, but I decided photography, I'd give that a go. So I've got this set up here. So a nice tall tripod with my camera on it with a telephoto lens, trying to get as far away from the subject as possible to minimize distortion. So trying to get a flat image plane. So yeah, I've got a light tent at the bottom with the knife in it on the fixture, and then yeah, camera. You can say I've got an image here that I've just taken, and if I zoom in, because it's pretty good. not super. Oh god, this is really confusing because the camera is rotated. Yes, you can see. Oh Jesus Christ! No, that way. Right, left and right are right and left, and up and down. Right, cool. So you can see here, we've got the. We can see all the steel parts in plan view nicely, and you can see the edges, and they're not occluded or anything. So that's so the alignment's pretty good. You can see the pins because they're very tall. We're looking down on about 20 mil of maybe even 25 mil of pin. So I'm going to make a shorter set of pins for doing this because I don't want the pins occluding the round hole in the blade. I want to be able to image the whole hole so that I can get a good unambiguous view of where the hole is in relationship to the edges of the blade. I'm doing this particularly to image the existing shape of the screwdriver, the Phillips screwdriver that I'm replacing with the horse's hoof tool. So I'm going to use the back end of the screwdriver. So I want to just capture the profile of that and then import it into my computer and then draw the rest of the shape of the tool. Some parts are quite rounded over. These have probably been tumble polished, tumble finished relatively aggressively. You can see on the corners of the these sort of lobes here that they're sort of quite rounded over. But that's fine. It just means that we're going to have to be a bit careful when we trace the outline to not get the true outline, not the kind of edge where it's been rounded over to some sort of arbitrary shape. So yeah, just a bit of care required, but yeah, pretty good. You can see the two marks there. I've just resized this roughly. I'm going to now resize it accurately. I'm doing this in Inkscape. My normal CAD tool of choice is FreeCAD, but it's going to be a real pain with all of these really organic shapes, at least to begin with. So I think I'm going to see how far I can get with Inkscape. I think I can probably do the whole thing in Inkscape since it's not that complex. I don't need sort of a lot of constraints-based modelling to get it right. Okay, I want to now capture the shape of the hoof tool on the equestrian. So I've just put a bit of masking tape on here. And just going to do a bit of brass rubbing just to pick up the edge. I do love this technique. It's so low tech and yet simultaneously magic. And the precision is that you get is really extraordinary. Now I also want to try and pick up the what's it called? The nail. It's called something. Nail nick. Which is like that. So a bit more precision scrubbing, and I should pick that up as well. Brilliant. My nail nick will probably be in a slightly different place, but It's good to have more information than less. Cool. All right, so now I just peel that off gently. And I'll stick that on a bit of paper and scan it. Alright, so I have imported the scan of the brass rubbing of the horse hoof tool. Here it is. So what I'm going to do now is I'm going to trace the shape of the hoof tool and then use that as the basis for the tool design. So here's the final design of the horse's hoof tool. You can see that it pivots nicely around its pivot point. In its closed position here, you can see that the position of the tool is defined by the position of these two lands here on the back spring. So where they intersect with the back spring tip, that interaction sets the closed position. And then you can see there's a nice smooth cam here, so there's a lower opening force than there is the closing force. So there's a fairly gentle cam there, so it's nice and easy to open with your fingernail. But then in the open position, it clicks more firmly into place in between these two walls here and this sharp point here. And then that provides more of an abrupt force for the closing force. So it's a little bit harder to close the tool than it is to open it. And you can see when it's in its closed position, the tip of the tool doesn't collide with the back spring. It just comes down into this space here, and that's nice because it means that the tip of the tool won't wear against the spring. And you can also see that through the whole travel, it clears the edge of the magnifying lens just barely. So that's that, and then I just cloned it into these shapes here and printed it out in black and white ink onto toner transfer film to get it onto the metal. Okay, I've got my print here on blue press and peel transfer film. This material is sold for making rudimentary circuit boards. I find it's pretty rough and ready stuff, so I can't imagine it doing a great job, but it does well enough for this kind of process. So I'm just going to transfer this image onto my piece of steel. Okay, I've got my little plate here on the back side. I've scuffed it up with some 280 grit, and it's been on here about a minute, so I reckon it's equilibrated to the temperature of the hot plate. So I'm just going to carefully lay down the piece. God, this is difficult. And I've put down these extra plates so that I've got something to roll the roller onto, because that's kind of helpful, I think. Now you're supposed to be able to use a domestic iron to transfer the image onto PCB. That might work for PCB, but the thermal mass of this steel plate is so high that that just doesn't work at all. So I'm using this hot plate here. I've got this set to 170 Celsius, and that seems to be about the melting point of the toner, much higher, and the backing film starts to degrade. Any lower and the image doesn't seem to transfer, so it's quite a fine-tuned thing. It's quite easy to get air bubbles trapped under the transfer film, and that stops the image transferring in that area. I don't know quite what you're supposed to do with circuit boards. Maybe it's less of a problem with the clothes iron, but I found that I had to repeat this process a couple of times until I got it reasonably bubble free, but I still had a couple of bubbles here and there. So, spot the continuity error. I ended up making this part twice because I drilled the hole through the horse's hoof tool almost a millimetre out, completely scrapping it apart. So I had to start again. So from here on in, here's a fresh print. Okay, that's really good. Good, we've got a perfect transfer there. So Yeah, next is an insurance policy against this getting scratched during the angle grinding step. I'm going to just etch this in ferric chloride, and that'll obviously etch this exposed region and leave it as a kind of matte, white greyish kind of finish. And then under here it'll be this dark, shiny kind of look, which will, allow us to differentiate between the two if this image does get scratched, or if chunks of it get flaked off or something in future steps. Right, I've got the bit masked off, and I've got a little tab of tape so I can get it in and out of the ferric chloride. That's some couple hundred mil of ferric chloride at about 40 degrees, a bit over maybe. I'll just leave that in there for 5 minutes, give it a bit of a swill every now and again. Well, keep it moving is best. Okay, here it is after etching. What is it with chemistry? Why is it so bloody unreliable? Or at least it is for me. Anyway, it's etched. It's just the last one etched and left this nice even white grey coating all over. Whereas this one, I've got these nice black streaks here, which are just going to make it slightly more annoying to work with, because it just reduces the contrast between this dark blue and the surrounding white. God damn! What is it with chemistry? Never mind. I can still work with this. It's absolutely fine, and it's doing the job. It's insurance for the future. If this scrapes off, if something goes wrong and I lose some portion of the transfer, well, it's going to look very different, because as you can see, this looks very different from that. Right, onwards. Also, I've got a 2mm center drill in there. It's important when you're drilling stainless to use good quality drill bits that are razor sharp. I mean, life's too short for inferior quality drill bits anyway, but that's particularly important in stainless because it work hardens like hell. So as soon as it work hardens, if the drill's rubbing for any reason, maybe if you're trying to drill it too fast, or the drill bit's a little bit dull, then the hole will work harden, and then you're really screwed. Then really you need carbide or diamond to get any further. So let's do it. I don't anticipate any problems with this. Famous last words. So you want to use slow cutting speed, and you want to keep the pressure on. That's fine, that's cutting nicely. And I'm going to drill through 2.2. I'll even give it some cutting oil. And then the final diameter, which is 2.5. This is the rivet pin diameter in the, well, yeah, obviously. Cool, no drama there. All right, so I'm really happy with how this has gone so far. I've been, as you saw, I cut it with the angle grinder to sort of rough it out, then the belt sander and bobbin sanders in the pillar drill to kind of refine the shape, and it's pretty spot on. I've kind of gradually snuck up on the various edges. There are a couple of regions here where the as I was grinding, I managed to burn off the toner. I was pretty careful to try and keep it cool with water while I was cutting, but as the material thinned down here, thermal mass obviously comes down, and it's much easier to burn it off. But luckily, with the etch, that actually was pretty visible. So this area is quite shiny. The surrounding area was kind of matte, dull grey, and that was easy enough to resolve. So I haven't lost any extra material or cut that to the wrong shape. So happy with that. So really happy with how it's come out. The finish on the edges is quite good. The bobbin sanders little drum sanders I was using were 120 grit, so I'll be able to refine this with higher grits without losing the kind of general squareness of all the edges and so on. So so it's amazing how good those little cheap kit of drum sander bobbins is. I was expecting it to be really rubbish, but it's actually pretty good. They're relatively square. The drum is relatively square to the shaft, so they do give you a pretty parallel or perpendicular edge. So yeah, pretty good. Not bad for a 20 quid little set, or probably even cheaper than that on Amazon. Versus an actual bobbin sander machine, which would be much more than that, of course. So next up, I'm going to refine the 2 to 10 regions with files. Because obviously I can't get into there with any sort of sander. So I kind of, again, I've got my edges visible in the toner still, so I'll creep up to them with various needle files and so on, testing the fit on the fixture until I get a nice detent at either side, and the right kind of opening and closing forces and so on. All right, let's do it. I'll give this a test fit. Okay. Oh yeah, that's actually pretty nice. A little bit stiff, which is what we want. We don't want it to be loose. And that's nice. That heel there is absolutely spot on. That is lovely. And this all clears the lens, which is obviously a requirement. So yes, looking good. So that just could do with being a little softer, that closing detent, but yeah, pretty good so far. So we'll just keep opening that up a bit. We haven't actually got to the line yet, so that's kind of as expected. Fantastic. All right, after a lot of finessing with with the files, I've got this working really nicely. It's got a nice closing detent when it comes to rest here. The tip of the tool is not colliding with the back spring. It's resting on the heel here like it's supposed to. It's easy enough to open. So yeah, it's got a nice closing force, not too crazy. You can overcome it very easily. I think you'll be able to grab it with a fingernail in the slot easily enough. Yeah, dead happy with that. It's also important that when it's in the closed position, there isn't too much load on the back spring, because if there is, it's difficult to open the opposing tool here, which is something that I'd kind of slightly forgotten about, but it all worked out all right. I had to very slightly remove some more material around the bottom corner here of the hoof tool just to account for that. I was also measuring as I went across here, so I could actually see how far the back spring was deflecting out, at the sort of 0 position, it was 17.3. So I was kind of looking for that measurement when the tool was kind of stowed and when it was fully deployed, and trying to get that measurement the same in both cases and the same as it was with the Phillips tool. So yeah, dead chuffed. That's all done in terms of shaping. So now it's just heat treating and polishing, and then finally grinding the finger slot, whatever it's called, the nail nick. Right, here's the setup for grinding the nail nick into the hoof tool. I've got the hoof tool glued onto an angle plate on the y-axis, and I've got the wheel mounted on its mandrel. I've arranged it, got the angle of the nail nick right, glued it vertically, and I've set the height by just scuffing the surface and doing it by eye. So ready to do the grinding. I did a test piece and I figured out that I need to grind about 0.6 millimeters deep. Ideally it would be deeper, but then the slot gets too wide. I think the radius of this tool is a bit bigger than the one that Victorinox use. They probably use one that's about 50 mil diameter, but it's good enough. It leaves a pretty nice looking result, and it feels good enough to open the tool with. Alright, that's a nice looking result. Look at that nail nick. Isn't that a fantastic professional look? I love that. It was bringing strong Victorinox vibes as well to the whole thing. So really pleased with that. It looks fantastic. And let's see how it feels. Yeah, and get a good grip on that with my thumbnail. That's great. Fantastic. Next for the heat treat. So I've got this stainless steel foil. I'm going to wrap the hoof tool in it while I heat treat it, or at least while I harden it, and that will reduce oxidation. So I'll just make a little pouch and seal it in. Right, there it is. That's all ready for heat treatment. The SF100 is hardened by heating to 1080 Celsius for
30 minutes and then either air quenching or plate quenching.
Right, I'm going to plate quench the hoof tool now. So take it out of the kiln. Oh, that's hot. Fucking hell. Oh shit. That could have been better optimised, but we should have worn gloves. Alright, so we can take it out of the plates. Oh, that's why. Cool. So the cooling rate is not too critical for this, as long as you cool it faster than 2 minutes, which this easily will have done. Okay, yeah, that's in pretty good condition. Bit of oxide, but not too bad. So that should be hard now. Yeah, that's hard as a coffin nail, as they say. So next up, annealing. So I want this more or less as soft as this steel will go once heat treated, which is about 54 Rockwell. That's about appropriate for a prying tool like this. We don't want it to be glass hard or anywhere close, obviously. So that's 350 degrees for 2 hours. So I sanded up through the grits from about 360 up to 1200, and I failed to actually film any of that. So here is some footage of me using the Dremel to finalize the polishing inside the various features I couldn't get to with sandpaper. And here I'm buffing with Dialux green buffing compound on a Swansdown mop. And there's the finished hoof tool, all polished up with the nail nick, everything's done. Still works beautifully. Lovely mirror finish. Yeah, really pleased with that. So thanks for watching if you got to this point. Again, please do comment and let me know how I can improve, because I've only just started making videos and I've got a long way to improve. So yeah, thanks.